Hello students, today I am going to explain hydrochloric acid chapter which we have completed till the special funnel arrangement, and now I am going to continue with chemical properties of hydrochloric acid. Hydrochloric acid, chemical properties. Chemical properties of hydrochloric acid. The first chemical property of hydrochloric acid is that hydrochloric acid is a monobasic acid. So hydrochloric acid is a monobasic acid. Now let us understand what is the meaning of the word monobasic. Monobasic acid means what? Remember, whenever, like say any acid, when it dissociates to produce one hydrogen ion per molecule, the acid is said to be monobasic. And if the acid dissociates to produce two hydrogen ions per molecule, then it is called as dibasic. And if an acid dissociates to produce three hydrogen ions per molecule, then it is called as tribasic acid. So since our topic is like why hydrogen chloride, it's a monobasic acid, we can say that when hydrochloric acid is dissolved in water, one molecule of hydrogen chloride will produce one hydrogen ion per molecule, and so hydrochloric acid is called as a monobasic acid. Now the H plus ion which is formed will combine with the water molecule to form hydronium ion. Now let us understand some other examples of monobasic acid. Nitric acid. Nitric acid is also a monobasic acid, because when nitric acid is dissolved in water, one molecule of nitric acid will produce just one hydrogen ion per molecule. Next acid, it's acetic acid, CH3COOH. Now acetic acid, when dissolved in water, also produces just one hydrogen ion per molecule of the acetic acid. Now CH3COOH is called as acetic acid. Formic acid, which is HCOOH, it is formic acid. Formic acid. Formic acid is also a monobasic acid, because when formic acid is dissolved in water, even formic acid will produce one hydrogen ion per molecule. And in all these cases, the hydrogen ion which is formed will combine with water molecule and will produce hydronium ion. Now let us understand like which ion is responsible for the acidic character of any acid. Hydrogen ion impart acidic character to the given acid when dissolved in water. So the ion which is responsible for acidic character, it's hydrogen ion. Or else we can also write that hydronium ion is also responsible for the acidic character. As we know that hydrogen ions are responsible for the acidic character, let's understand a solution of hydrogen chloride in water exhibits acidic properties and is an electrolyte Now, hydrogen chloride when dissolved in water exhibits acidic properties and it also behaves as electrolyte. Like what happens like when hydrogen chloride is dissolved in water? Water being a polar solvent ionizes polar covalent hydrogen chloride molecule into free ions, and the free ions which are produced, it's hydrogen ion and chloride ion. And as I've said earlier, that hydrogen ions are responsible for acidic character of the given solution, and ions are responsible to carry electric current through the solution. So if the solution conducts electricity, there will be free ions present in it. And in this example, the free ions are hydrogen ion and chloride ion. And so a solution of hydrogen chloride in water also behaves as an electrolyte. So the explanation which you all can write as water being a polar solvent, ionizes polar covalent hydrogen chloride molecule into free ions, and the free ions which are produced, out of which one of the ions, it's hydrogen ion. So hydrogen ion is responsible for the acidic character, and the solution will behave as electrolyte because again free ions are responsible for it, because free ions will conduct electricity. But if hydrogen chloride is dissolved in some organic solvent, then it does not exhibit acidic properties and is a non-electrolyte. So we can say that a solution of hydrogen chloride in organic solvent such as toluene, or we can say like toluene, does not exhibit acidic properties and is a non-electrolyte. Now when we compare it with the explanation which I have written above, what is the difference? Like the difference is in the solvent. Here the organic solvent which is used, it is a non-polar solvent, or else we can say it is not a polar solvent. So if it is not a polar solvent, the polar covalent hydrogen chloride molecule does not dissociate to produce H plus ion and Cl minus ions. So if hydrogen ions are not produced, obviously like the solution will does not like exhibit acidic properties, and since like there are no free ions, the solution will behave as a non-electrolyte. So the explanation what you all can write, it's toluene not being a polar solvent does not dissociate hydrogen chloride molecule into free ions. And if free ions are not produced, the solution will behave as non-electrolyte. No hydrogen ion means the solution will not exhibit acidic properties.